What's going on, everybody? Got another video for you here. This one we are going to do integrals, and it's the basic logarithmic form. So let's go ahead and get started. So first thing, we've got the integral of du over u is equal to the natural log of the absolute value of u plus c. So basically what we've got here is we've got a fraction, and notice that the derivative of the denominator is in the numerator. See, we've got u here and we've got the derivative up here. And that's the logarithmic form. So that's equal to the natural log absolute value of u plus c. Now make sure when you write this, you put the absolute value to ensure that we're taking the natural log of a positive number. Okay, so make sure you have the absolute value there. There's some instances where you don't have to put it. I don't know if we run across any of them in these examples. If we do, I'll point it out. If not, I'll explain it, towards the end of the video. All right, so our first example here, we've got the integral of dx over x plus 1. All right, so the main goal here is to get this integral to look like this. We need to get du over u. And the way we're going to do that is using u substitution. So we've been doing u substitution in all the previous videos, okay? So what do you think we're going to let u equal? Well, we're going to let u equal the denominator, okay? So let u equal x plus 1. So basically what we're doing here is we're testing to see if the derivative of the denominator is in the numerator. That's what we're checking. So if I let u equal x plus 1, and I know obviously you know that the derivative of x plus 1 is 1 dx. You can do that in your head, yes. But for now, let's just write it down so we can see it. And so du is equal to dx. That's the derivative of this. And so now you can see the x plus 1, I'm going to replace that with u. And you can see dx is going to be replaced with du. So let's make that substitution. So I've got du over u. And you can see it's in this form now. And so now I have natural log absolute value of u plus c. And then we have to get it back in terms of x. So that's natural log absolute value of x plus 1 plus c. And there's our answer. Okay. All right. Let's go to the next one. All right. How about this one? And yes, you probably can see it. The derivative of sine is cosine. You see that? But let's write it out. We're going to let u equal sine x. Du is cosine x dx. So there we have it. Look at that. The sine x, that's going to be replaced with u. And then look at this. You see the cosine x dx? See, cosine x dx, all that is going to be replaced with du. And so I have the cosine x dx, I'm going to replace that with du. And then the sine x, I'm going to replace that with u. And you can see now I have it in this form. That's what we're trying to do. That's what you're trying to do when you're doing the integrals like this. And so now that's going to be natural log absolute value of u plus c, which is equal to natural log absolute value sine x plus c. I just put sine x back in the place of u. And so there's your answer. All right. So, those first two, they were pretty easy. They're not bad. All right, so let's look at this one. All right, so for this one, let's try it. Let's let u equal 4 minus x squared. And so du is negative 2x dx. All right. So obviously in the place of 4 minus x squared, we're going to put u. But look at this up top. I've got x dx. See, I just have this part, the x dx. I don't have the negative 2 here, but we've done this in past videos where that's happened. So what do I need? I need a negative 2. So I can multiply by negative 2, and so that means I have to come out here and multiply by negative 1/2. Okay? And so now I have the negative 2x dx. I've got all of that now, negative 2x dx. So all of that can be replaced with du, and then the 4 minus x squared can be replaced with u, but don't forget the negative 1/2 out front. Okay? All right. And so now this is going to give me negative 1/2 natural log absolute value of u plus c. And then we have to get it back in terms of x. And so I get negative 1/2 natural log absolute value 4 minus x squared plus c. And there's your answer. All right. Now, before we go on to any other problems, let's just stop right here for a second. Okay? Now, a lot of times when we come to this section, students will automatically think whenever they see an integral with a fraction, it's natural log when you integrate it. But that's not the case. Remember what I said. If you have a fraction, if you can take the derivative of the denominator and that is in the numerator, then that would be natural log when you integrate it. Okay? Not because it's a fraction, but because the derivative of the denominator is in the numerator. That's what makes it natural log. For example, let's look at this problem that's a fraction, but the answer is not going to be natural log. So let's suppose we had this. This is another problem, okay, that I'm just making up right now. And let's do it in a little bit different color. So suppose we had this, x over 4 minus x squared dx, okay? So it's similar to problem 3, but we've got this in parentheses squared, right? All right. So what are we going to let u equal? All right, so in past videos, past lectures, we would let u equal what's inside the parentheses, right? So we would say u is equal to 4 minus x squared, so du is equal to negative 2x dx. And then same thing, we'll multiply by negative 2, come out here and multiply by negative 1/2. And so that's going to give us negative 1/2 integral. Now look at this. You see the negative 2x dx? Well, all of that's going to be replaced with du. So that's going to be du over, and then the 4 minus x squared, see the 4 minus x squared, that's going to be replaced with u. And so that's going to be u squared. You see the squared there? See, the derivative of the denominator, in this case, the derivative of the denominator is not in the numerator. Okay? Because look, if I let u equal the denominator, right? That's the denominator. Well, what's the derivative of this? That would be 2 times 4 minus x squared to the first times the derivative of what's inside the parentheses, right? That's what I would have if I did that. And you can see clearly that the x dx, that's not even close to that. So we're letting u equal what's inside the parentheses, not the entire denominator. So don't just think because it's a fraction that it's going to be natural log. And then what would we do here? That would be negative 1/2 integral u to the negative 2 du. See, we got to move this up. And so that would be negative 1/2. And that would be u to the add 1. So that's negative 1 multiplied by the reciprocal of the new exponent. And so that would be 1/2 times 1 over u plus c, which would be 1 over 2 times 4 minus x squared plus c. You see the difference? Okay. So whenever you see a fraction, yeah, that might be the first thing I try. See if the derivative of the denominator is in the numerator. And if it is, just go on and work it like we did here, and it's probably natural log. But also be careful if it's in parentheses, raised to a power, or maybe this is a square root or a cube root or something like that. Okay, so you've got to be careful of that. All right, let's go to the next problem. All right, let's try this one out and see what happens. All right, so let's just see if the derivative of the denominator is in the numerator. So I'm going to let u equal 1 plus 3e to the 4x. And so I've got du, now let's write it over here. So I've got du is equal to derivative of 1 is 0, and then derivative of this, that's 3e to the 4x times the derivative of the exponent times 4 dx. And so I've got du is 12e to the 4x dx. All right. So you can see in the numerator, I just have this part. I don't have the 12. So what am I going to do? I'm going to multiply by 12. That means I have to multiply by 1/12 on the outside. That's like multiplying by 1, right? We've discussed that in detail in previous videos. And so this is going to give me 1/12 times the integral. Now, look, all of this, I'm going to replace with du. See, all of that, I'm going to replace with du. And then the 1 plus 3e to the 4x, I'm going to replace that with u. And so I get 1/12 natural log absolute value of u plus c. Okay. And so this is 1/12 natural log absolute value 1 plus 3e to the 4x plus c. All right, and there's your answer. Now, let me say this. In this problem, yes, I put absolute value, but I didn't have to in this problem. I could have just used parentheses there. But I'll say this, whenever I'm doing the integral and I get natural log as an answer, I'm typically always putting absolute value. Okay? So, but in this one you don't have to, and why is that? Because if you look at this, you see the e to the 4x, that's never going to be negative. This right here, this 3e to the 4x will always be positive. And then if I take a positive number and add 1, that's always positive. So this will never be negative. So you could use parentheses if you wanted to. All right, let's look at the next one. All right, so this one we have to evaluate. So we got a fraction, so let's see if the derivative of the denominator is in the numerator. So u is equal to 1 plus tangent 2 theta. So du is derivative of 1 plus tangent 2 theta. That's derivative of 1 is 0. Derivative of tangent is secant squared 2 theta times the derivative of what you're taking the tangent of. So what's the derivative of 2 theta? That's just 2, and then times d theta. So you can see we have secant squared 2 theta, d theta, that's what we have in the numerator. We're missing the 2, so I'm going to multiply by 2. That means I have to come out here and multiply by a half. And so this is equal to 1/2 times the integral, and that's going to be du over u. Now, remember we're using u substitution, so let's go ahead and change our limits. All right, so I've got 0 and I've got pi over 8. And so I've got u equals, and that's going to be 1 plus tangent of 2 times 0, which that's tangent of 0. 2 times 0 is 0, so tangent of 0 is 0. 0 plus 1 is 1. And then I have u equals 1 plus tangent of 2 times pi over 8. All right, so 2 times pi over 8 is pi over 4. And the tangent of pi over 4 is 1. All right, tangent of pi over 4 is 1. 1 plus 1 is 2. All right, and so we have 1/2 times natural log, absolute value of u from 1 to 2. And so that's going to be 1/2 times natural log of 2 minus the natural log of 1. And so the natural log of 1 is 0. Remember, anytime you take the log of 1, no matter what the base is, that's 0. And so our answer is 1/2 natural log 2. And there's your answer. And yes, you know, if you wanted to, you could punch that in your calculator, but really there's no sense in it, so just leave it like that. All right. So let's take a look at this problem. All right, it says Newton's law of cooling states that the rate at which an object cools is directly proportional to the difference in its temperature, capital T, and the temperature of its surrounding medium. By use of this law, the time, little t, in minutes a certain object takes to cool from 80 degrees to 50 degrees, and that's in Celsius, in air at 20 degrees Celsius is found to be this. T equals negative 9.8, and that's going from 80 to 50 because it's cooling from 80 to 50 degrees, dt over capital T minus 20, and they want us to find t. So basically all we're doing here is we're evaluating this integral. And so to do this, we're going to let u equal capital T minus 20. So du is equal to dt, because the derivative of this is 1, and then times d capital T. And so I have t is equal to negative 9.8 integral. Now, the d capital T I'm going to replace with du. And then the capital T minus 20, I'm going to replace that with u. And then what else do I have to do? I need to change my limits, right? I need to change the limits because I'm in terms of u now. And so I've got u is equal to 80 minus 20, which is 60. So that's 60. And I've got u is 50 minus 20, which is 30. And so that's 30. And so I've got t equals negative 9.8 times the natural log absolute value of u, and that's from 60 to 30. And so t is negative 9.8 times the natural log of 30 minus the natural log of 60. And let's see, what does that give us? That gives us 6.8 minutes. And that's your answer. All right, so that wasn't too bad. So let's take a look, and I believe this is the last problem here. All right, it says find the volume within the piece of tapered tubing shown in the figure. I haven't drawn the figure yet. I will draw it. Which can be described as the volume generated by revolving the region bounded by the curve y equals 3 over square root of 4x plus 3, x equal 2.5 inches, and the axis, okay, bounded by this curve, x equal 2.5, and the axes about the x-axis. So basically what we're going to have here, if you remember if you remember what we did in the video on disk and shell method, that's what that is. And so if I graph this thing, that's going to look something like this, and we're going to revolve it about this axis. Now, how do I know what this graph looks like? Well, I looked at the answer. That's why. This one, I mean, think about it, you got to graph this thing. You would have to look for asymptotes, vertical and horizontal asymptotes, critical numbers, increasing, decreasing, concavity, inflection points, all that good stuff. Okay, which that problem would if we worked this problem out, it'd probably take us 30 to 40 minutes to work that problem, going through it. So just refer back to that part of the class. We're revolving about the x-axis, and so we've got, remember, you got your rectangle here. All right, if you're not understanding how we're setting this up, then you would need to go back and watch the video on disk and shell applied calculus, disk and shell method of disk and method of shell, cylindrical shells, whatever. I can't remember what I called it, but it's in the playlist, applied calculus. So go back and watch that. That goes into more detail about how to set this up. All right, so we've got the volume is equal, remember, pi times the radius squared. So look, and remember, we got our line here, x equal 2.5. This is 0, so we know we're going from 0 to 2.5, and it's the radius squared, pi times the radius squared. Well, what's the radius? That's the distance from here to here. Well, what is that distance? That distance is y, right? What's the thickness here? That thickness is dx. Well, this height here, this radius is y, but because this is dx, we need y in terms of x. So that's going to be 3 over the square root of 4x plus 3 squared times dx. All right, so there we go. We've got that set up, and I know I didn't explain it like I did in the previous video, but you're supposed to already know how to set this up. Okay, and so this is equal to pi from 0 to 2.5, 9 over 4x plus 3 dx. All right. And now we need to integrate this thing. So what's the derivative of 4x plus 3? The derivative of 4x plus 3 is 4, right? Well, we got a 9 up here. So that doesn't match. And I hope you remember what I told you in previous videos. If you take the derivative, if you're using U substitution, you take the derivative and the number doesn't match, go ahead and pull that number out. That's what I like to do. And so we've got 1 over 4x plus 3 dx. All right. And so now I'm going to let u equal 4x plus 3, and du is equal to 4 dx. Now, why did I tell you to pull the 9 out? So let's suppose we didn't do this step. Okay, let's suppose we didn't do that. So I've got 4 dx right here. Well, up here I've got 9 dx, right? What do I need to multiply to 9 to get a 4? I mean, no, it's not that difficult to figure out what it is, but it's easier if we just pull the 9 out and we come up here and we say, okay, I need a 4, so I need to multiply by 4, then I come out here and divide by 4. You see how that's easier than trying to figure out what do I need to multiply out here? Okay? You know, what do I need to multiply to 9 to get a 4? It's just easier to do this. That's why I say just pull the number out. Okay? All right, so now we've got 9/4 integral. And so, look at this. The 4 dx is going to be replaced with du. And the 4x plus 3 is going to be replaced with u. And now I do need to change my limits. And so I have u equals, I'm going to plug the 0 and the 2.5 into here. So that's going to be 4 times 0 plus 3 is 3. And u equals 4 times 2.5 plus 3. And so I've got 4 times 2.5 plus 3. That is equal to 13. All right, so I'm going from 3 to 13. And so this is going to give me 9/4 times natural log, absolute value of u, and that's going from 3 to 13. And yes, on this, you could put parentheses instead of absolute value because both of these numbers are positive. And so that's going to be 9/4 times the natural log of 13 minus the natural log of 3. And when we punch that into our calculator, let's see, natural log 13 minus natural log 3, and then times 9 divided by 4, we get 3.3. Ha, and look what I did. Did I do something wrong in the problem? Yes, I did. What did I forget to do? And no, I did not do it on purpose, but I'm glad I did it. I forgot to bring the pi down with us. See that? We should bring the pi down. Let's erase this. 9/4 pi. And so if I multiply that times pi, we actually get 10.4. We'll say 10.4, and that's going to be cubic inches. Okay, so yes, I forgot to bring the pi. I just got caught up explaining why I pulled the 9 out. I was focusing on that, explaining that to you, and the different why you should and shouldn't, and how it's easier to do it. I just got caught up in that and forgot to bring the pi down with it. Okay, honest mistake. All right. So, but yeah, that's the end of the video. I hope it helped. Check out my other videos. Give me a like, share, and subscribe. Thanks for watching, and I will see y'all in the next one. Later.